I'm now going to introduce you to a very, very important data structure. In some sense, this is the most important data structure. It is used often in many, many pieces of code. And by the way, I'll let you in on a little secret. When you start preparing for job interviews, if you want to work in the software industry, you will often find that many of the problems they will ask you about can be solved efficiently with this data structure. So it's a very, very useful and important data structure, and it gets used in many places. So I'm going to motivate the use of this data structure with some actual data that I have taken from this NCERT's National Achievement Survey. So this is conducted every few years, and it examines the performance of school children in different subjects. Here I'm showing you the performance nationally of school children in various classes on mathematics. So the question I'd like you to think about is, there's lots of such data that we might want to process. Now, how can we represent tabular data in Python? Well, one answer is to represent it as a list. After all, the data is basically a bunch of numbers. So I have a list of integers. I've put here some comments next to each number to remind me which number is corresponding to which grade. And now, if I want to know what is the score of class 3, I know that is index 0 in this list. But imagine I have written this code somewhere, I have initialized this list, and then somewhere later on in the code, I want to examine two of these numbers and compare them. So if you now read this code, having forgotten that list, you might wonder, what is maths 2? Which grade does that correspond to? And which two grades are we comparing over here? We would have to remind ourselves that maths 2 really corresponds to grade 8, because that is index 0, index 1, index 2. And maths 3 corresponds to grade 10. So we are here comparing grades 8 and 10. But that is not obvious by just looking at this code. So there's a cleaner way of representing this kind of tabular data, and that is using a dictionary. So instead of initializing maths inside square brackets, which is a list, we will initialize maths inside curly brackets. Now, curly brackets is also a way in which we indicate sets. But the difference is each item within these curly brackets is going to be of this form: some key and then colon some value. So the key is going to be like the name, and then the value is going to be like the definition. So this is called a dictionary because it resembles a familiar dictionary that you use for looking up meanings. There, the key is a particular word, and the value is that word's meaning. So if we ask what is the type of this thing, it'll tell us it is a dictionary. And in this dictionary, I have 4 items. Each item has a key, which is in this case a string, and an associated value, which in this case is an int. Now, when I write the code to compare two grades, that code is suddenly much easier to read. I'm comparing if the math score for class 8 is less than the math score for class 10. This will look up in this dictionary what is the value associated with the key 8, and the value associated with the key 8 is 255, and the value associated with the key 10 is 220. So this statement will not be true, and we will avoid this if condition. But you see how much easier it is to read this code than to read this code, where we would have to remember what index 2 and index 3 corresponded to. So this is very useful.